The first law is one of the 4 fundamental axioms of thermodynamics. These laws cannot be proved analytically, but their existence has been thoroughly proved, using experiments, like Joule's experiment. We all know this statement: energy can neither be created nor destroyed, that is, energy is always conserved. The first law is essentially another form of this statement, but adapted to represent thermodynamic systems. If you take any system, it possesses some energy within it. In thermodynamics, we are interested in the energy of a system, due to its temperature. This is called internal energy. When we do any work on a system, its internal energy increases. For example, if you put your finger in a glass of water and move it very fast, the temperature of the water increases. This temperature increase might be so small that we don't notice it, but it still exists. Just like how your hands heat up when you rub them together, the particles of the fluid rub against each other, causing an increase in temperature. But when the temperature increases, heat also gets dissipated, unless we intentionally prevent it from escaping. And when this heat escapes from the system, the internal energy goes down. Since energy is always conserved, this work done on the system must have been the reason for the increase in internal energy. Similarly, the heat escaping from the system must have been the reason for the internal energy decreasing. So, the internal energy change is equal to the work done on the system, minus the heat lost. Since heat and work have a direction to their flow, that is, they can be added or taken away from the system, we have to follow some sign convention. Here, the scientific sign convention is, heat supplied to the system is a positive number, and heat dissipated away from the system is a negative number. But work done on the system is a negative number, and work done by the system is a positive number. An easy way to remember this is 2 hip when. When given to the system, heat is positive, and work is negative. So in the earlier situation, work is done on the system, so is negative. And heat is lost from the system, so is also negative. Here, W and Q are the letters used to denote work and heat respectively. So, the change in internal energy, denoted as delta U, is equal to Q minus W. This is the equation for the first law of thermodynamics. If we did 10 joule of work on the system, and 5 joule of heat is lost from the system, then by first law, the internal energy will increase by 5 joules. The internal energy may also be expressed as specific internal energy, which is just the internal energy per unit mass of that system. Enthalpy is closely related to internal energy, but is different. When matter expands or contracts, that is, when its pressure and volume change, there is some energy it possesses. When we include this energy along with internal energy, we call it enthalpy. For some systems, it is useful to look at the enthalpy, since it gives a more complete picture of what is going on.